It is again a privilege and opportunity to listen to Dr. Kalidas from IIT Tirupati. We have experience of listening to him in the previous one of the short-term course with Engineering College Bikaner during the month of July. So we have thought that okay, he will be the best person, appropriate person for covering the one of the important aspect IR. Which is like how to prepare the data, how to pre-process it. So let me share or let me introduce our expert. So Dr. Kalidas is currently working with the Computer Science and Engineering Department IIT Tirupati. His research mainly focused on the theoretical and applied aspect of machine learning and artificial intelligence in the domains like smart infrastructure, education technology, and bioinformatics. So he has his PhD and MS in year 2010 with IIC Bangalore, so which is the prominent institute of our country in the topic of algorithm development for large-scale data analysis of molecular structure. And for that work, for PhD work, he got best thesis medal in SERC department. So after completing this PhD part and PhD work, he has affiliation with the two basically well-known IT companies. Like first one is Samsung. For there he was 3 years, and he worked on the topic of smartphone data analytics, genomics, and video stabilization. After that, I spent around 3.5 years with Amazon on basically machine learning scientist in the topic of advertising recommendation and Kindle document layout analysis. So thank you, Dr. Kalidas sir, so to joining us in this FDP. Now I would like to hand over this session to you. Thank you very much, sir.
Thank you very much, Dr. Vikram, and thank you very much to the organizers of the faculty development program, and thank you very much to all the participants for giving me this opportunity and platform to interact with you. So in this talk, I'm going to talk to you about vector-oriented representation, thinking, formulation, and a small example on how we used it for information retrieval. So with this, I would like to share my screen and then start the presentation. So I am intending to switch off my video for some time in the interest of bandwidth, and I will share the screen. Please stop me anytime if anything is not clear.
Right, sir.
So please tell me if my computer screen is visible.
Yeah, it's perfectly visible, sir.
Thank you very much. Just give me half a minute. Some other mobile is ringing. I'll put it off in some other room.
Right.
1 second. Hello, everyone.
Yes, sir. Yes, sir.
Yes. Sorry about that brief interruption, but we'll be uninterrupted from now onwards. Sure. So, vector-oriented thinking and machine learning problem formulation is my topic of discussion I have put forth for the forum today. So, what is vector-oriented thinking and how do we formulate machine learning problems? This is something very interesting for all of us working in the area of data science. There are some facts, there are some myths. What I mean to say is there is scope and limitation of machine learning problem formulation. So it is worth to see from different people what are the scopes and limitations. So you can think of it as one perspective from me. There may be several other perspectives as well. So let us start our discussion on this. What is vector-oriented thinking? So there is a lot of buzz. There are two buzzwords today: AI, ML, DS, deep neural networks, right? Artificial intelligence, machine learning, deep learning. Okay, so we have machine intelligence, data science. What is science in data science, right? So like that, today whole job market is bombarded with these words. So as faculty, it is important for us to understand what is inside them. So all of us would have taught, like several of you would have taught artificial intelligence course, or some of you would have taught machine learning course or deep learning course. Like the different courses we teach, definitely, but at the same time, from another faculty perspective, from the insights what we gain perspective, let us share our thoughts about this. So several people have different philosophical opinion about artificial intelligence. When it comes to managers in the industry, their perspective is different. They want something which can reduce the cost of calculation, which can reduce the cost of a product cost that reduces, and they will be very happy to assume that machine learning can accomplish anything in the world. So any human can just be replaced by a machine. That is what their perspective. They tend to think like that because it is cost saving for them. When it comes to scientists who do not use these techniques, their assumption is it can do wonderful discoveries on behalf of the scientific work, on behalf of the scientist, without their having to do some experiments. Automatically the machine will give output of great findings, great results. So that is their perspective, some scientists. And some engineers, several engineers, they also think that, okay, machine learning is there, so I input this product on the left side, the machine learning transforms it, and a transformed product I get on the right side. So I don't need to worry about this black box. Black box is there, it will give high quality product. So this is the thinking of a general purpose engineer. But those people who are working in the core algorithm side of machine learning and who are working in the core algorithm side of artificial intelligence, they know what is a fact and what is a myth. So let us look at what are the facts and myths in this domain. So the agenda of my talk will be, first I will introduce vector-oriented thinking. The next part I will talk about vector representation and reasoning. Third part I will talk about loss function perspective of the whole world. Fourth part I will talk about scope and limitation of machine learning. Fifth part I will talk about a vectorization example applied to video scene retrieval. So these are 5 points in my agenda of talk. So first let us look at vector-oriented thinking. So does anyone think what's happening here? So I would request someone or other to keep answering a small question or something I ask. These are all subjective questions, nothing right, nothing wrong. So to be interactive, to know that you are listening my voice and following what I'm saying, I just want to be a little bit interactive. Can anyone kindly tell me what do you guess is happening here? If you have to say one phrase that's in my mind, can you guess that phrase? What's there? Anyone, please?
Yeah, so participants are requested to reply and respond to these observation, whatever you're observing by looking at.
You can just unmute and tell, because if you type in chat, I won't be able to see that chat. So I request you to please unmute and say. Please feel free.
There are different types of thought is there we find here, and different people thinking is different way. Some emotion, some are trying.
Yes. So yes. So you are very much close there. Let me just put it in the interest of time. People are having a set of thoughts. They are not having ordered set of thoughts, ordered collection of thoughts. They are having so many thoughts in a bag. That bag is their brain. So because the set of thoughts are there, that person doesn't know where to start. Where is the starting point? Where is the ending point? They don't know where to start. So an unordered set of thoughts is the problem, right? People will be confused on how to solve all of them, which is the first. Like when they're doing one thought, then something else calls for attention. Then that other thought calls for attention. So they will be like a tortoise trying to do so many things, but they can't run. So from a set, changing the thoughts to a list is something that is very interesting. So if you type in Google or any other search platform, thought management, okay, organizational management, process management, you will get, believe me, a lot of material. I have put some screenshots. Just in Google Images, I searched and put some screenshots here. So time slicing. So make the time as 1 to 9 hours, working hours, let us say. First hour I do this, in the next hour I accomplish this task, like the time slicing. You convert a set of thoughts to a list of thoughts. Thought diarying. So you jot down what are all the thoughts that are coming to you today. So tomorrow also if you are getting the same thoughts, so that you have a checklist, whether it is repeating or not repeating. Process management. So you have so many tasks to do in an industrial scenario. So you make note of all the processes and then connect them in the form of a chain. Process 1, this is first process, this is second process, this is third process. Put them in this sequence. Organizational behavior. You have so many modules to do. There are so many groups and subgroups of tasks. So create a hierarchy of them. So something has got to do with thinking. Most of the successful companies, most of the successful products, whatever are there, they are all about a thinking process. So thought is the first element before any implementation or physical exercise comes into picture, like what you are trying to actually do comes into picture. Thought is the fundamental thing. So let us look at what are the concepts that we have been using, which are actually thinking paradigms. For example, all of us would have written several algorithms so far, right? What is algorithm? Nothing but a step-by-step execution of several sequence of actions. There are sub-steps. There is a starting step. There is a stopping step. So I'm moving my mouse here, for example. Mouse is not visible, right? Mouse is not visible.
So the cursor is visible to us.
Cursor is visible. Okay.
Yeah.
So let me take that laser pointer. There is a laser pointer here. So
Really better.
yeah. So there are steps and sub-steps, starting and ending step. So this is called computational thinking. Object-oriented thinking. Several of us would have written Java programs. So before even writing Java programs, we should first have in mind what are objects, what is an object, what is instance of an object, right? A person is an object, each and every person. Kalidas is one instance of person, Vikram is one instance of person. So object-oriented thinking is fundamental even before we start to develop object-oriented programs or systems. Process-oriented thinking. Today, Amazon Web Services is very popular. Microsoft Azure Web Services is very popular. This is called service-oriented architecture, SOA architecture, right? So you have services, you have clients, you have service level agreements. The whole of this, the root is process-oriented thinking. If a person is not well rooted in process-oriented thinking, then he won't be able to develop any service-oriented architecture solutions. Table-oriented thinking. For example, all of us would have used SQL. For example, I am teaching DBMS also next semester. Vikrama is also teaching DBMS, right? So before even writing SQL programs, we should first have table perspective of the whole world. Given the scenario, our thought process will be, what are all the various tables in that? Once you know what are all the tables in that, student table, teacher table, connection is course table. So once we know the table perspective, table-oriented thinking, then we will be able to build relational SQL software. Similar to that, for machine learning also, there should be some thinking paradigm. The thinking paradigm is called vector-oriented thinking. So let us look at what is vector-oriented thinking. So for example, this is one instance of brain where there are so many parts responsible for motor control, speech, smell, coordination, and so on. If you look at that, it's just a tissue like this on the top left side, whereas they have identified all of the areas responsible for what function in the brain. Okay, so why is this important? Because we are talking about thoughts, brain comes into picture automatically. So that's why we are looking at this brain, and we will relate it to what is vector-oriented thinking very soon. So if you recall, if you are wondering how they have identified what regions of brain are responsible for what thoughts, they put a cap like this, electrode cap. So they will ask that person to read a paragraph. They will ask that person to walk. They will ask that person to smile. They will give that person some tasks to do. And based on what task that person is doing, which electrodes are active, they will say that this area is responsible for this action. This area is responsible for this action. Like that, they have identified the regions in the brain responsible for those actions. So let's look at this thought experiment now. So I will ask you a very simple question, and you should just answer whether it's doable or not. So would we be able to imagine that we are drinking tea in a glass of water in a glass, and then sugar is less, you put some sugar, and now the tea is tasting good. Do you think we'll be able to imagine this? Can anyone please tell me? So if you close your eyes and imagine there is a teacup, there is a cup of tea, are we able to imagine that cup of tea in our mind? Anyone please just tell me. Yes or no?
Yes, yes, I think.
We will
Yes,
be able to imagine, right? So
Yes.
actually there is no cup, there is no tea, right? It's only in imagination. So in the brain, if you recall, where is the tea? For example, corresponding to T, there will be some set of neurons where some voltages might be present. Corresponding to T with the spoon inside that, there will be some other set of neurons. Corresponding to stirring of sugar, there will be some other set of neurons active in the brain, right? So the whole brain, for example, if activity is happening such that some subset of neurons are getting activated, some set of neurons are getting deactivated. What do we think we can represent this brain scenario? Can anyone please tell me? What is the theoretical abstraction we can make for the whole brain? With some voltages being on in some dendrites, with some voltages being low in some dendrites. What is in principle or what is in theory we can represent this scenario with? Anyone please?
We can take a binary representation 0.
Excellent, madam. Fantastic. So we can actually think of it as representing by a very large array of numbers. For example, to relate to that, let me give one small example. Can anyone tell me what is there in this question mark slot? I put some circles question. What is there in that? Anyone please? What is there in this? Anybody?
Motherboard is.
Yeah, that is PCI slot is there. This is motherboard, PCI. So in this slot, RAM card will go. So in that slot, RAM card we will put. So there is something related to brain and the RAM chip. Can you guess what is the relationship? Anyone guess? There is some relationship between them. What is it? RAM?
Processing storage.
Something that we are actively doing.
Replacing. Actually, we can permanently cannot store anything. I mean, brain also cannot permanently. Some portion cannot store permanently everything. Sometimes after refreshing, we can basically memorize these things. Brain. Same way in RAM also.
So let us say transient also. So there is something related to activities.
Sir, it may be volatile in nature. Both brain and RAM both are volatile in nature.
Okay, I will surprise you with that. Like there is a different answer for that. So what is this? Anyone please tell me? Yeah, what is this? Some of you would be teaching operating systems.
Virtual memory using page.
Excellent, fantastic, right? So this is operating system table where way of dealing with memory management. Some part of the memory is code, some part of the memory is data. Okay, code segment, stack segment, data segment registers. You are storing code, you are storing data, you are storing memory there. But from a RAM chip point of view, does it differentiate code? Does it differentiate between data? Does it differentiate between whatever other types of stack function call sequence you store? Or it's just a sequence of bytes? What is it from RAM chip point of view?
Just a sequence.
Just a sequence of bytes, blob of bytes. So when you are loading the computer processor register with code segment, then that blob of bytes is interpreted as code by the processor. If you are loading that a particular register and pointing it to a particular region saying that this is data segment, then that blob of bytes is treated as data. Otherwise, from RAM chip point of view, everything is zeros and ones. I mean to say everything is a binary string, right? So now we are looking at this color photograph. There is a king, old king sitting there. So, and we are getting some emotions about it, that artwork is good, he is majestic, he has a sword, all that. But from a computer point of view, there are no such feelings, no such emotions. Everything is just an array of zeros and ones. Everything is an array of just pixel values, intensities. So this is the relation I'm trying to tell. In principle, the whole brain, we can represent it as a very large array of numbers where voltages are these numbers. This is not practical to do. No one can do that. I mean to say with the computational power what we have. In principle, theoretically, that's what I'm saying. So now, glass without water is an array of numbers. Glass with water is an array of numbers. Spoon is an array of numbers. Our stirring is an array of numbers. Listening, hand movements, thinking, understanding everything is now an array of numbers. That array of numbers we say is the vector representation. Okay, so let me tell you here. All the actions, motor control, touch, body awareness, language, reading, everything is a vector now. So there is an important take-home message from this small example what we have seen. The take-home message is a vector representation is extremely useful to us because whatever we have in our mind, whatever concept we have, we can actually use vector representation as a tool to write some software programs. And we say that those software programs are machine learning. And we say that those software programs define intelligence. We define intelligence and code for intelligence. The take-home message is a vector representation is the first step to be able to capture any type of concept. Okay, so why we are calling it vector? Because an array of numbers is not a vector. Okay, computationally you have vector data structure, all that, but what I'm saying is a vector has got direction, it has got a meaning. So when you change the array of numbers, there is a corresponding interpretation from the human side. It's not just magnitude. When you change the array of numbers, there is a meaning also, which a human can give meaning, and that's why we are calling it vector. So any question on this? Or shall we go to the next topic? I have some more things to talk about. So I'm saying vector representation is extremely useful. Yeah, please.
Sir, can be thought is a vector? Means in thought there is no direction. Means when we thought about glass of water, then what is the direction in it?
There is no direction, sir. Like what I'm saying is, when you are thinking about glass with water, so there are some voltages active in the brain. Am I right? That means that vector, the theoretical vector values would have changed. Am I right? So vector is something that has got more to do with meaning and semantics. An array of numbers versus a vector, the word what we used to call it, right? So it has got a philosophical meaning. For example, if I say velocity is a vector, speed is not a vector. Right? Speed is just magnitude. So in that way, a vector has got some meaning, interpretation by a human. That is what it is. If you are able to represent real world in the form of small vectors, vectors may be of 100-dimensional vector, 200-dimensional vector, or 1 million-dimensional vector, whatever be it, some vector representation, then you are onboarded with the machine learning thinking.
Yeah, so sir, actually, yeah. So in some cases, it is not so clear about the direction. Magnitude may be quantified or may be understood, but sometimes a representation of some aspect, that magnitude aspect is not that much clear.
In linear algebra, let us take linear algebra. Yes. Everything we got to do with vectors, right? Why are we not calling it array? Right? So array is a programming perspective of how the data is represented. It doesn't assign any meaning to it. Right. Okay, when you say vector, then you have the notion of this vector is close to this vector or not, cos theta between them, or how much distance is that, what is the determinant of matrix. All these are human interpretations of that set of vectors. Okay, that's why it is called a vector. Vector means there is some meaning associated with that array of numbers. That is what
one question is there.
Yeah.
Sir, if the thinking is a vector, basically voltage are working, direction of voltage according to this. So in a particular time, instance, while we are thinking, then we can measure this voltage or not. That means how we can measure this?
No. See, my intention is not to model the brain. We cannot model the brain that easily today in the whole world.
And I want to know that if we can measure this. So
See that. Okay. Please get my take-home message correctly. My take-home message is a vector representation is useful. That is all I'm saying. Because anything in the brain, we can, in principle, in mind, and theoretically, we can represent as a vector. It's not practically possible. Theoretically possible to represent as a vector. Now I am saying that a vector representation is a useful tool. That is all I'm saying. I'm not saying model the brain. Modeling brain we cannot do because it's so big. I mean to say, the vector size will be extremely large, and we don't have computational capacity and power to do that. Is it clear?
Yeah.
I'm saying theoretical vector. I'm saying theoretical. I'm underlying and bold facing that letter. Theoretical vector. That means in principle, activities in the brain. Yeah. Please.
But one thing is, we see that when we basically developed the technology, so some robots now you see that that means work just like as a human brain.
No, sir, they will not work. I will come to that. That is why I have put this lecture. Okay. So there is scope and limitation of machine learning. So there are some myths floating around. There are some facts. There are some myths. Myth means this wrong assumption. So a robot working like a human are all myth currently.
But emotion is not there. I know that emotion is not there. They cannot.
Not emotion. Like there is a limitation to our computational power. What we can program.
Okay.
I will come to that. I will come to that in next some 10 slides or so.
Okay, thank you, sir.
I will exactly cover that because that is something very important to clarify. I have put explicitly reserved some material for that to talk about that.
Okay, sir. Thank you, sir.
Okay, sir. Yeah, okay. Please. Let's take it that vector representation is useful, and if we look at what is representation is fine. What is reasoning? For example, if we look at what is reasoning, right? So in machine learning, you will find that there is a vector on the left side, xi. There is a vector on the right side, yi, and you map xi vector to yi vector through a pipeline. That pipeline is called machine learning. You learn that pipeline, how best you can map xi vector to yi vector, and that mapping mechanism is accomplished via a loss function. We'll see a little bit more on that. So before going to that representation and reasoning, I said, right? So by the way, anybody knows who is this man?
No. We cannot identify basically.
Any guess, please? He is having some compass in hand, no? And there is a slate. And looks like King's time. He is not current time. He's Euclid actually. Euclidean geometry, right? He's Euclid. So in mathematics, there is this notion of space, Euclidean space, Hilbert space, Banach space, like that. The word space is there. And that word space is very much different from the word space what we see. Like in the Gravity movie, for example, we know of space means stars are there, planets are there. No, that is not that space. The word space in mathematics is actually a data structure in computer science. Okay, it took me a long time to realize that. So the word space in mathematics, whatever they have used, is nothing but data structure what we use in our day-to-day life. Euclidean space, Hilbert space, and Banach space. Let me tell you what it is. So in group theory, there is this concept in group theory. Plus is a binary operator. Why is it a binary operator? Anyone please tell me?
It is binary operator. This operator is working while we find two operators.
Yes, it is taking two numbers.
Binary which is in between two operands, used with two operands.
So it is taking two numbers and outputting one number. It is a function actually. Am I right? It is a function that is mapping, taking two arguments as input and outputting one element, right? So minus is a unary operator. Why is it a unary operator? It is also a function which is taking one number as input and outputting another number. Am I right?
Yeah.
So,
yes.
So the real numbers combined along with this concept of operators plus multiplication, minus, and then some things like inverse of a number, some things like identity element, inverse element, all of that. That is about reasoning of the data what you represented. You have a space of real numbers. On that space of real numbers, reasoning is happening via operators, plus, minus, into, all that. So if you have a space of vectors, reasoning is happening about what do you guess could be the reasoning? Instead of 3, instead of 4, instead of 4.1, whatever it is, if you have some vectors, what do you think reasoning would correspond to? I told you that reasoning is all about operators and the pipeline of these operators. Can anyone tell what is the correct phrase for that, please? Operators that take vectors as input, as simple as that. Okay, if you have a set of operators which take as input vectors and output vectors. That's reasoning. That's defined as reasoning in the space of vectors. So let's look at this example. If you show left side equation, solve this equation, right? So the points where it touches x-axis, let us say, cuts x-axis. A mathematics trained person will be able to calculate roots of this equation. Whereas the same person may have difficulty understanding this concept here. What is on the right side? Anybody guess what's there on the right side? It's some software system. So it's some autonomous driving software system. Whereas the person who is trained in this software architecture may have difficulty solving this equation. So here there are operators which are nothing but plus, minus, into, derivative operators. Here also there are operators, object-oriented operators are there. When it is getting two inputs and it is outputting something. In both places, the training is different here and the training is different here, but both are actually building very robust systems. One person is building robust system for solving equations. Another person is building robust systems that are running autonomous driving. It is doing here. So why these both things are working? Because both are not trained mutually in each other's domain. Reason is representation and reasoning is all about operators that you define and is all about the data that you represent. Whether knowingly or unknowingly, this person is still a mathematician, I would say. Whether knowingly or unknowingly, this person is still an object-oriented thinker, I would say. Okay, so how do you represent data? How do you represent operations is the critical thing to vector representation and vector reasoning also. For example, if I say, Ram said, I do not think it will rain today to Shyam. Then Shyam said, there is a forecast for rain, let us see. That means there are two people, Ram and Shyam, they are talking. So Ram said that I do not think it will rain. And then Shyam said that there is a forecast for rain. So object-oriented thinking will create a scenario like this. We'll create a person for object for Ram, person object for Shyam, then speaker object, then it will create a speakable object. That means a sentence is a speakable object. Then it will create actions for speaking object and hearing object. It gets a speaker, put speech in that, get a listener, put speech in that. So this is how an object-oriented thinker will design the system. That is actually a reasoning part of what the data is represented. Data is represented as objects, and reasoning is accomplished in the form of functions that you are defining and the transformations you are doing. So same thing here for vector representation. You have to be able to identify object. You have to be able to identify the properties of the object and be able to write in the form of an array of numbers and know the meaning of it. Then you say that it's a vector. For example, examination object, if you take, how many students are appearing, when it happens, what is the average mark and standard deviation. For example, a person, for example, army selection is there. Age is a set of pixels. Each and every pixel is a attribute of that object. Video, it has composed of several images, right? Each pixel set of the image or pixel list of the image itself forms a concatenated big vector. Audio, so time sliced measurement of amplitudes is audio representation. It's a vector of numbers. Text, whether a particular word is present or not present in the dictionary, that's a vector representation. So you represent data in the form of vectors, exactly like how you are able to represent in object-oriented fashion. You be able to identify objects and represent in the form of vectors. Then you bring in the power of mathematics into this. The power of mathematics is brought into picture by defining vector operations. What are the vector operations? For example, dot product is a vector operation. Summation is a vector operation, right? Matrix determinant is a vector operation. Right? So angle between two vectors is a vector operation. So when you define operations over these vectors, you are actually reasoning about those vectors. The vector representation and reasoning becomes critical to machine learning. So yeah, I told you about reasoning. Any object literally in the world, you can identify as object, any concept in the world, any civilization today, anything you tell, I can always find an object-oriented representation for it. Any concept in the world. That is the highest level of abstraction we are having today in human civilization. Object-oriented abstraction is the highest level of representation. So once we are able to represent an object in the form of properties, we be able to roughly map saying that these properties are related to these properties. Once we identify objects, pairs of objects that are related, that have some relationship between them in the form of what properties are related to what, then we have scope for using machine learning. If we cannot identify objects, then we cannot use machine learning. If we cannot identify an object and represent as a vector, then also we can't use machine learning. If you can identify object, represent the object in the form of a vector, and roughly know these properties of object 1 are related to these properties of object 2, then you can use machine learning. Vector representation and reasoning. The mapping is the reasoning part of it. Okay. So you would see that age value, height value. So what is object there? Age object, height object. Okay, age concept object, height concept object. You can always relate them, right?
Excuse me, sir.
Yeah, please.
Sir, in object-oriented, the properties of all objects are same. Then how will you find the properties of one object is and the properties of second object are equal? Means
For example,
all objects of the same class have equal properties.
No, I am saying object is class also is an object. If you look at object-oriented thinking, in Java you differentiate between a class and an object. Even at the JVM level, if you see, even class is also an object. Class is also an object. Everything is an object. That means a concept is an object. And instances of that concept is also an object. Is it clear?
Yes, sir.
Yeah. So object-oriented thinking doesn't say doesn't differentiate between a class and the instance of a class. No, everything is an object for object-oriented thinking. That I am saying about this. Instead of object, you can imagine as a class.
Basically, in general, everything is an object. But when you consider that we can differentiate object and class during the runtime of the program, basically. But in general,
See, yeah. So this is a theoretical or conceptual map.
yes.
You do this mapping in paper and pen. You are not doing this mapping in implementation. You are not writing a single line of code for this. You are only writing on paper and pen. You are identifying object types and saying this object type is related to this object type, or this object is related to this object because of these properties, rough relationship between them. Only in paper and pen you have to do that. Only once you do that, then you can apply machine learning.
Yeah, we can make the relation between two objects. It is not a problem.
Yeah. So sometimes what happens is the objects will be so trivial that you don't even need to write on paper and pen. You will just say age and height, they may be related. Actually, implicitly what's happening is age object is there, height object is there. One attribute it is having, another attribute it is having. A vector of one dimension, a vector of one dimension, you are relating these two guys. Okay. So let's look at this linear regression example. Can anyone tell me what's happening here? What's happening here? Anyone please guess, just guess something else.
Types of
We are fitting a line, right? There are some coordinates and we are trying to fit a line. So in your opinion, which line is good? Red one is good or blue one is good? Gray one is good? Which is good?
green one.
Green
The
one looks
minimum
good.
error.
Either blue or green looks good to us, right? So let us see what are objects there. So you have x coordinate object and y coordinate object. Okay. So so where the abstraction takes you, that's what. So you have x coordinate value, you have y coordinate value. You are relating this left side object to the right side object by a relationship. These two are related. Okay. It's a vector of one element. It's a vector of one element. And machine learning is a technique that maps left side vector to the right side vector. Okay. So you are able to map only if you are able to identify vectors. You are able to map only if you are able to identify objects and corresponding vector representation between them and identify relationship between these two vectors. So we have representation as x1, y1, x2, y2. xi vector is mapped to yi vector. Xi vector happened to be just one dimensional. Yi vector also happened to be just one dimensional. So, but the concept doesn't restrict it to one dimension. It can be any dimension, doesn't matter. 10,000 dimensional here it can be 20,000 dimensional, doesn't matter. So, x is called, left side is called capital X, right side is called capital Y, target or label. So, you would have heard about it in machine learning class already. I'm going to skip some of this. So, mapping is a process which takes each and every element of X and then maps it to corresponding Y. Okay, that is the pipeline what we are talking about. How do we configure a pipeline which maps it the best possible way, best criteria? F is called model, model fit, model prediction. So I'm going to skip all of this. So when you pass left side X to the function, it gives a predicted Y called Y, right? So that's called prediction. So all right, let's look at this. For mapping left side to right side, you may have several different choices. X square is a possibility, cubic curve is a possibility, or a line with slope and intercept form may be a possibility, or parabola is a possibility. We don't know which one is the best mapping mechanism. So we have to evaluate all these possible mechanisms programmatically. That's called hyperparameter search. And then choose that mechanism which is best mapping left side to right side. We need a goodness badness measure. Let's look at that. So we will step into something very important thought perspective, loss function point of view of the world in machine learning, which is very important. So if we are fitting a line through 2 points, x1, y1 and x2, y2, can I say this is one possible equation? Is this equation right, or any mistake is there? Can anyone say, is this right? This is correct, right? So I'm not hiding a secret answer and asking. I'm just asking for interaction purpose. This is right. Is this right?
I mean, that might be because that, yeah, yes, it is.
Yeah, just x1 by 1, x2 by 2, we are connecting by a line. That's all, mx plus c. So, line passing through 2 points, x1 by 1, x2 by 2, we are able to determine. So, but we have to map 5 points here and 2 5 y coordinates there, 5 x coordinates to 5 y coordinates. Now, if we want to fit a line, we can always find equation of line passing through 2 points. What about the remaining 3 points? What do we do about those points? Right? So, machine learning has got something to address this. So, you are able to think of a line. When you thought of a line, you need 2 points. You took 2 points, fitted a line, no problem. But what about other points? That's where machine learning comes into picture, how it addresses. So, okay, one answer may come from linear algebra perspective. Substitute the points. Substitute x3, y3, substitute x4, y4, substitute x5, y5. You substitute, fine, and do what? Right? That question still hangs around. So you are taking 2 points and then trying to substitute in other points is not the solution. You need a measure which is some value of m and c, which is best. So goodness badness measure is fundamental or inherent to machine learning thinking. So passing through 2 points, finding a line is not the solution. You think of line as mx plus c, and then define y1 should be mx1 plus c, y2 should be this. They won't be exactly same. There will be some difference for given value of m and c. The difference will be there. So let's craft a goodness badness measure. Badness measure for x1 y1 is the difference between actual minus predicted whole square is called squared error. So you sum up all those badness measures for all the points and say that that is my loss function or error function. Okay. So this problem is called linear regression problem. So it's called regression problem because you are trying to regress, come back to actual value by minimization of the loss function with its parameters m and c. And you have ground truth and you have predicted values. You have a formula for the squared error function and trying to reduce that error. So let's come back to this point. So we want to start with some line and then systematically explore different possible lines and come to this best fitting line. So how do we explore different possible lines? You have this notion of solver coming into picture. A solver takes a loss function as input and then starting value of m and c, mx plus c, m and c are the parameters, and then explores different possible values and then outputs the best possible values. In principle, you can have different types of solvers. I just put theoretical brute force solver, theoretical random solver. So you have a gradient descent solver. That is the method what is predominantly used. This is a smart way in which you converge to the best possible solution. So in machine learning, you formulate the problem as X on the left side is a capital X matrix and Y on the right side is a capital Y matrix. You relate them. The pipeline is this: XW is equal to Y. This is the linear regression formulation. So though it is conceptually linear regression, you can extend it to any other concept as well. I'm going to say quadratic curve fitting, right? So for passing, fitting a line passing through origin, your capital X will be x1 to xn n by 1 matrix, and your y, capital Y, will be y1 to yn n by 1 matrix, and you define a loss function which is xw minus y transpose xw minus y. This is the squared error loss function, and then find the best possible w. You want to learn this w from data by iterating as w new is w old minus gradient of L taken at W is equal to W old. So you can use the same formulation for slope and intercept form. X matrix is changing here. You can fit for a parabola. X matrix is changing here. You can use it for cubic curve fitting. Only the capital X matrix and W are changing here. Degree K polynomial, capital X matrix, and then the W vector are changing there. Right? So the formulation is W new is W old minus eta times grad L at W is equal to W old. Grad L is called the gradient function. It's called steepest descent formulation. And W is the parameters what you are trying to find. Mx plus c, that value of m and c is what you are trying to find. So this is all about this. Some of you would have done a lot of courses, all that is fine. But let us look at the thought perspective behind what is going on here. So if we find equation of a line passing through 2 points, can anyone correct me if I am wrong? Is this correct line? Is this line passing through these 2 points, please? Anyone, please? Just substitute and tell me. Is it passing through these 2 points? Passing, no? It's passing through these 2 points. Yeah. So does it pass through this also? -1, 1 also? This line, 3x plus 4. Does it pass it through -1 and 1?
Yes, sir.
It passes through, right? So does it, instead of this point, if I give -1, 2, does it pass through this?
Error of 1.
It won't pass through that.
Yes,
Right.
there is an error. Yes.
Yeah. So linear, you say linear algebra point of view, you say that it doesn't pass through that. It comes with true or false assertions. So does it, how many lines can pass through just 1 point? 0, 4. How many lines can pass through 0, 4?
Infinite.
Infinite number of solutions, right? So if I give xw is equal to y, okay, if there are k variables and n equations and rank of capital X matrix is R, okay, if R is greater than k, then there is no solution. If R is less than k, then there are infinite number of solutions. Okay, rank of the matrix determines whether I have infinite number of solutions, unique solution, or no solutions. So non-ML world, the focus is on the rank of the matrix. This is the critical observation I would like to request to take home. In the non-ML world, the focus is on rank of a matrix, whether how many solutions it has, right? Whereas in the machine learning world, it disappears. You have the notion of a loss function. How much loss is there and whether we are minimizing that loss function. That is the fundamental step in machine learning world. That's the thing which has driven the progress so far. You move away from solving a system of linear equations in terms of unique solution, multiple solutions or no solutions, but bring the loss function into picture, the whole perspective changes. And you can apply a number of problems to that. So loss function L of W here is xw minus y transpose xw minus y. When you expand it, you get a expansion like this. Xi vector is mapped to yi vector through a loss function, which is minimized in the pipeline. So ML scope, if you ask 5 critical things in the machine learning, let us look at those 5 critical things. Designing of xi vector is a critical thing. Designing of yi vector is a critical thing. Designing of a model is a critical thing. Like given x, I want to predict the corresponding y. What function I use? XW should I use or some other function I use? How do I map xi to yi? That is a critical thing. Third critical one. Fourth critical thing is the loss function. How do you design that loss function? Is it squared error or is it mean absolute error? There are several types of errors, no problem. Logistic error, hinge loss, right? So loss function is a critical thing, and having a data set is a critical thing. X1 by 1, X2 by 2, Xn by n. So in the machine learning, these concepts become critical. Left vector on the left side, vector on the right side, a model that maps x vector to right vector, a loss function that calculates how good or how bad that mapping is, and a data set on which that loss function has to calculate its goodness badness measurement. In unsupervised learning, you may think you don't have the yi vector, what should I do about it? But unsupervised learning is mostly about pre-processing category. You do some clustering and then keep separate data aside so that separate models you can build, or you send it to a manual team or visualize the data. So unsupervised learning, the word learning for unsupervised itself is a philosophically debatable concept. Whereas if we look at the machine learning, the word learning corresponds to how you map xi to yi vector. And these are the 5 critical things. So there is a scope and limitation of this. Let's look at the scope and limitation of this. I will come to the limitation right now. Can anyone tell me and guess what's happening here by just looking at the screen? Can anyone please guess what is happening? Your guess may be right or wrong, doesn't matter. Just you can have subjective opinion. Just want you to guess what's happening there. You can read the slide, please.
Sir, it seems swapping type of problem.
Jug problem, basically. You have 2 water jugs. Okay. So, and then you have to output a given water capacity by doing jug transformations. For example, I may give you a 5-liter water jug and 3-liter water jug, and I will ask you to output 4 liter. What will you do? You will do some operations like fill first jug, then transfer to second jug, empty second jug, transfer first jug to second jug. Like that. Finally, you can output the given capacity. Then one movie Die Hard. Has anyone seen this scene, Die Hard movie scene? Say yes if yes. I'll be happy to hear.
Looks similar to Tower of Hanoi.
Yeah, so there is a movie called Die Hard. Okay, so in Die Hard movie, bomb scene is there. So they have to do these jug transformations, put on that weight sensor, and it will disarm that bomb. So please see that scene, fantastic scene. So this jug transformations, can we write a program? Do you think we can write a program given 2 jug capacities and given output? Can we automatically calculate what operations to happen and output should come? Do you think it is possible to write a program?
Yes, sir.
Right, it's very simple code, just about 20 lines of code you are seeing on the bottom right corner. Very simple piece of code. You can write a program which will output this sequence of moves. You can have several solutions for the same output 4 liter. You can have different possible operations, no problem. Okay, so now I will ask a question. Can you generate 1 lakh such examples programmatically? J1, J1 capacity, J2 capacity, output capacity, and the sequence of moves. Is it possible to programmatically generate 1 lakh such sequences?
Yes.
Yes, right? Now I will ask you a question. Can you write a machine learning algorithm which uses this formulation to automatically solve any given jet capacities and output that sequence of moves? Can you write a program? Can you formulate in this framework? Can anyone tell? whether they think it is formulatable. Can you formulate it? I'm saying no, it is not possible. Okay, so there are some types of reasonings which you cannot accomplish by pure vector operations, addition, subtraction, multiplication, or if statement, such as rectified linear unit function. So definitely today, as of now, as this lecture is happening at this time, right? We don't have technology which can learn from several such examples and then automatically figure out the sequence of operations for given two jets. It's not possible. Today, it is not possible. So then you can imagine, can robots think like humans? We are far away from that. So let's look at this. Yeah, please. Someone is having a question. Please. Hello? Yeah, please. Let me come here. I will give another example. So let us say there is a smoke on the mountain. Mountain trees are there. There is smoke on the mountain. And now can we say that there is fire on the mountain? Anybody please? There is smoke on the mountain. Now I am saying if there is smoke on the mountain, then there should be fire on the mountain. Can anyone tell that is fine? That reasoning is fine or not fine? Hello? Anyone please?
Yes.
Right, it makes sense, right? Very common sense, right? If there is smoke on the mountain, then there should be fire on the mountain.
Fine.
So how we are able to reason it? Because in that person kitchen, let us say there is a old type kitchen where wood is burnt to cook things. So if wood burns, then smoke comes. So now has wood of kitchen is true. Has wood of mountain is also true. There are so many trees. That means mountain has so much wood. So is kitchen of mountain is true. You can write fact like this. Is kitchen of mountain is true. Is kitchen of has wood of X is true. Anything that has wood is a kitchen. Is like a kitchen. Okay. So when smoke comes in, is kitchen of some Z. Then when smoke comes in mountain, then mountain should be like kitchen and it should have fire in that. So this type of inference is called deductive reasoning. So you have some facts, you combine the facts and generate new facts. For example, if I give you an array of numbers, okay? Now I want you to calculate maximum element in that array. What do we do? To calculate maximum element in that array, what do we do? Some very simple step. We take the first element. Okay, we assume that is maximum.
So
Then
assuming first element to
be
greatest.
Yeah, we go to the second element and then update the previous fact. Is maximum of the previous element is wrong, so change the element, right? So then you take the third element, max index you keep track of. So you can always represent certain type of operations such as counting, such as maximum number calculation, such as sorting in the form of facts. In the form of facts that change over time. When the for loop iterates, the max index is changing. When the for loop iterates, max third element, max fourth element, those indices are changing. Those types of reasonings are called deductive reasonings. Can anyone guess who is on the left side photo?
Mr. Ramanujan.
Who's here?
APJ Abdul Kalam.
Abdul Kalamji, here who is here? Einstein is there.
Albert Einstein.
Very obvious, without any. Yeah. So can anyone tell what's here? Left side? What is this?
Time.
Piece or time pico. It can be.
Time
piece, right? Like very common. Time piece. So can anyone read this paragraph, first sentence? Can you just please read it once? Anyone, please read it.
So when I was walking up the road for usual home errands, I saw something very strange. Usually we only expect to see things things routine. I don't know what is written here.
That are
routine.
that are
Routine, not
routine and
that
not
okay. Our not expect any rises.
Anything,
surprises, right?
Surprise.
So we are able to guess, right? After some couple of trials, we are able to guess here, right? So what we are doing here is interpolation. We are interpolating from our knowledge of, we saw Srinivas Ramanujan photos several, and then given a photograph with blank, we are able to interpolate it. We saw APJ Abdul Kalamji's photo, several of them, and we are able to interpolate. Einstein photo, we saw several, and voice with breaks. I put voice also with breaks. So when we make phone call, we are able to guess the other person's sentences, right? Even if there is some noise in the line, right? So we are able to interpolate from our knowledge. Vector interpolation can fill the gaps. This is called gap filling. We are able to fill these gaps by simply doing vector interpolation. We have a bunch of vectors corresponding to this image, bunch of vectors for this image. We are able to interpolate based on our vectors what we have. For example, if I show a different photo, you may not be able to interpolate because you don't have those vectors. So vector interpolation is all about filling gaps. Whereas there are a class of problems which you cannot model it as vector arithmetic. Parity learning. For example, if I give string of zeros and ones, so you have to output 1 if it is an odd number of ones. You have to output 0 if it has even number of ones. Parity. Divisibility testing. You have two numbers. You want to see if one number is divisible by the other or not. Histogram learning. You have an image, right? You want to calculate on the right side yi. How many pixels are there of intensity 12? How many pixels are there of intensity 20? Something like that. You cannot. So minimum, maximum. If I give an array of numbers, you have to calculate which element is maximum on the right side. Sorting. Left side is an unsorted array. Right side is a sorted array. Believe me, machine learning cannot do that. All these types of reasonings are deductive reasonings. So we have submitted a paper for ICLR. We are waiting for the reviews. So we have created a data set of about some 10 data sets where today's RNN and today's deep neural network fails miserably on simple problems such as minimum, maximum, top second element, binary representation, sorting, divisibility by 3 test, parity testing. So even if you look at parity problem, right, random forest may give 92% accuracy, but that is a very pathetic number, I would say, because anything less than 100% is not desirable for parity problems, such a simple problem as this. You will very soon see that if you have a binary number having 50 bits, 50 numbers, right, you will require 200 petabytes of storage for a decision tree to give 100% accuracy. If you have 1000 bits, then you require 1000 into 4 into 2 power 1000 storage space for a simple problem as parity problem. So some things which are trivial by deduction are non-trivial in this formulation of xi yi formulation, which is the machine learning formulation. So what I mean to say is feature engineering is something that industry does day in, day out, right, on engineering better features. You convert your understanding, engineer a feature, and that feature becomes a golden feature. Today, deep learning methods are causing a myth, or people are biased thinking that if you use deep learning, then no need to do feature engineering. Absolutely wrong. Deep learning is also an xi to yi mapping mechanism. Any deductive reasoning you cannot accomplish with the deep learning with the current, as of we're speaking today, with the current set of operators what you have. You have only vector multiplication operator, you have vector addition operator, and an if statement, which is the ReLU rectified linear unit. They are not sufficient to do deductive reasoning. Okay. So, any question on this? I would like to hear any question on this.
Yeah, so if any participant is having some doubts or some queries, it can be raised by simply enabling audio. Yes, please. Yes, so I think we can continue, sir.
Okay. So we are seeing a lot of papers, several thousands of papers, on using deep neural networks for doing all types of tasks. But actually, what's fundamentally myth is there are problems where deductive reasoning comes into picture, where inductive reasoning, which is basically a vector interpolation, cannot be used for those tasks. Vector-oriented reasoning, vector interpolation is fantastically useful in a number of engineering problems, like interpolation type of problems. There are 99% of the problems are interpolation type of problems. I mean to say simple problems or interpolation type of problems. But as soon as we start to say that whether robots can behave like humans, you see this simple test, it has failed miserably. Today's technology can't even do these simple tests. Okay, so we are far away from a human-like robot because deduction cannot be done through existing machine learning formulations, be it deep learning, be it machine learning, whatever word we use for that. Xi to yi mapping through vector operations of simple addition, multiplication, if statement cannot be or not sufficient for deduction type of reasoning. So with this, let's move on to this. So given that this talk is about information retrieval, I will talk about vector representation and how we applied it for video scene retrieval. Given a video scene, we are able to retrieve similar video scenes in the database. My student Prashant carried out this work. Prashant, are you there?
I am here, sir.
Yeah. So let me show some simple examples. So this we submitted to CVIP and they accepted it kindly. So we applied it for retrieval and anomaly detection. The task, I will directly show the output so that it becomes clear. Right? Example is better than preset. So a query scene will look like this. You are able to see the video?
Yeah.
So there is a person, horse is going on. Now we may have a million videos and scenes. We have to retrieve similar scene. So this is the scene that it retrieves. Are both scenes similar? Do you think?
No.
Some similarity is there. No, horse is there. Horse is moving.
So object basis it is okay, but I mean, except this horse and a person background, I mean, these two details are matching. I mean, other the details are not matching. Means background is different and other objects are different.
Other objects are different. So it should be tolerant to other objects and retrieve this. That is what we purposed it for. So in this video scene and in this video scene, we defined important object as horse that is moving and ignore the other objects and try to recover the moving object, which is horse with a person on it. So this is one example I will show for video retrieval example. So what we did was, till now I talked a lot about vector representation. So now I will take this paper as an example to say how we vectorize the data and how information is retrieved using that, given that this is retrieval FDP. So you take a video scene and represent that video scene in the form of a vector. That is the fundamental first step. So a scene, we have defined a scene as 8 seconds video scene. That means if we take a video sequence recorded at 30 frames per second, 8 seconds corresponds to 240 frames. So a scene is a list of 240 frames. Now, how do we represent a scene as a vector? Once we are able to represent scene as a vector, then identifying similar scenes becomes vector proximity search. So what we did was we detected subregions using object recognition, and for each subregion took all the pixels and then represented it in the form of a vector. And within a scene, we have traced all these vectors and then identified the cluster of the objects that are moving. For example, in a scene, one person may be statically present, like not moving. In the same scene, there may be a second person who would be moving. So what we will do is, we will identify the moving person separately. We will identify the static person separately in the scene. So, and for the moving person, we give a text representation saying person 1 underscore moving, person 2 underscore static, person 3 underscore stationary, cycle 1 underscore moving, right? Or car 1 underscore moving, car 2 underscore stationary. So like that, we convert a video scene to a text. It's called scene text. And from the scene text, again, represent it in the form of vectors using any text vectorizer such as count vectorizer, TF-IDF vectorizer, or hashing vectorizer, and use that vectorizer for the scene to retrieve the similar scenes. So that is one application of vector representation. So also we have query, like the query scene, it will be converted to a vector. There is a database of scenes which are already offline vectorized, and the KD tree will identify similar scene and then give it in the retrieved answers. Top 1 match, top 2 match, top 3rd match. So we have also modified this to a distributed database scenario where we have several video databases may be situated across different locations. Given a query scene, the scene vector will flow to each of those databases and their corresponding front end, and then parallel search happens. Once the retrieved results come, again one more KD tree of n number of hierarchies happens and then retrieve the top few scenes in a distributed fashion. So this is the power of vector representation.
Yeah, so at this point, sir, there is a query from the participant that how to convert video scenes into the text. So that is the question, sir.
How do we convert?
Yeah.
Okay. So I had skipped the detail, but I will explain it. So what we have done was like take the coordinates of the object that is stationary, that is sitting in the video scene. If the coordinates are stationarily there in one position, then we will say that that object is not moving. That means if you calculate x comma y, x1 by 1, right? In this frame it is x2 by 2. In this frame it is xn by n. So in all this x and y 1, if you calculate the standard deviation, and if the standard deviation is less than a threshold, then we can say that it is stationary. If it is more than a threshold, then we can say that it is moving.
Now, one question is that how we can set the threshold in this case?
So threshold has to be hyperparameter. Manually, we have to identify, test on scenes and set it.
Actually, manually, it depends on the scene, no? Suppose.
Sorry?
So manually, how we can basically assume based on scene or based
there are, yes, I will tell you. So in all these machine learning formulations, for example, let me go here to this XIYA formulation. In all these formulations, right, this loss function, there will be some human controlled parameters. I told you that not everything machine can do automatically, right? For example, this problem. In the same way, hyperparameters also, we cannot do machine learning for them. We have to, human only has to set them. So in the same way, some parameters we only have to set it because we can't learn all the parameters automatically. Some thresholds, some goodness, badness, brackets, all that.
Okay.
Does it address your question, sir?
Yeah.
Not everything is automatic. It's not possible to do everything automatic. Human element has to come. Wherever deduction reasoning is there, subjective interpretations are there, human element has to come. So that is the human element what we have put in here.
Suppose in your scene, we find the bicycle and the human activity of bicycle, I hope that riding of bicycle is there.
Correct.
Okay. So suppose the scene is different types of scene is there, then how we can basically set the threshold?
So, for example, if a person is, so what we have done was, we have gathered some 1,000 scenes. In those 1,000 scenes, we have manually inspected how the thresholds are corroborating with whether actually it is moving or not moving. Like that, we have chosen the threshold. That is the human element. So it may not work for all cases. Definitely, one solution will not work for all cases. So,
Sir,
there will be
since
corner
there are
cases where it will not work. Yeah. Please.
Sir, as in the example, there are 7 images displayed in front of us. Usually, KD tree has a limitation till 8th dimension to work smoothly for nearest neighbor problems. So, whether the whether the choice of the images are specific for the problem statement or
No, this
they
is
have some
only for
kind.
illustration. We have 240 such frames.
Okay.
So each frame, there will be several sub-objects. For example, in this frame, person is there, right? In this frame, cycle is there, some signboard is there, like that. So each frame itself will have several objects. For each object itself, we will get one vector. So we'll get one vector per object. So like that, a scene will create a data set of vectors.
Sir, here I have one question. What do you mean by the scene window? Scene window is one type of matrix representation.
We have
Window.
taken scene as 8 seconds video clip. That means 240 frames as a scene.
Scene window, I am telling about the in your block diagram. First input is video, then pre-processing object detection, then third block is scene window. So here
Yes.
scene window means matrix representation.
So scene window means it's a list. It's a frame I to frame I plus 239.
I plus 239.
Yeah. So it will have 239 minus 0 plus 1, 240 frames. I changes. I moves from 1 to I plus 1, I plus 2. So we have taken a step of 240. So because
basically, you can find out the frame. Basically, while we actually analyze the video, so first we find the video, then we find the scene, then we find the frame, then we find the suppose the image. We basically objects or
that
images.
all has to happen here in this step.
So in this case,
given a
scene
video,
window means for collecting the frame. I hope that.
Splitting the video into frames. Yes, we have to split the video into frames.
Okay.
As into huge list of frames. For example, if the video clip is 5 minutes, we will get 5 into 60 into 30 frames. We will get.
Yeah. Understood. Now
About some 5,000 frames or 6,000 frames. So my main purpose of this is what I wanted to show it as a power of vector representation. If you are able to represent a concept in the form of a vector, here I have we have represented scene as a vector. We could have represented some other concept as vector. For example, subtitle sequence as another vector, audio clip as another vector, right? So vector representation is the critical step in machine learning. So if you are able to represent vector, then you can use the power of it.
Sir, one problem is that in this case, when you find the angular object in scene, angular
means, for example,
angular means suppose the face are not straightforward. Some problem.
Okay. Profile, like the person face may not be fully visible, right? So it will miss some cases. Definitely, it will miss some cases. So what happens is when for each frame you are creating a vector, right? In some frames, that person may have turned right side or left side, and in some other faces, that person would have been facing front, right? So when the objects are clustered, okay, the clustering will have that information on for each person. For example, whenever he was looking front, that forms one cluster. Whenever that person is looking right, that forms another cluster. Whenever that person is looking left, that forms another cluster. So it will,
we can represent this, but I want to tell you about the identification of the person from video. Is it good way vector representation? for identification of a person from video.
You don't want to identify a person in this video. See, the idea is this representation doesn't target for identifying a person. So by the end of this representation, we are not asking who is there in that video. No, we are trying to only group the objects in that video, whether some object is moving or not moving. For example, if there are two people, let us say one person is sitting stationarily, another person is moving, let us say. Then what happens is, for that person who is sitting stationary, if we just go for person detection, we will just output the word person. There are two persons, therefore we will get the two persons detected there. We will not have any information about who is moving, who is not moving. Whereas in this representation, what happens is, for that person who is stationary, that vector representation will be same across all the frames because he is not moving, XY coordinate is same. For that person who is moving, what happens? That pixel array combined with X, Y coordinates, that will be changing over the frames. So when we cluster it, what happens? In that cluster, right? So all the persons who are corresponding to the same person will have same vector representation. For example, if I take a pixel array, so in a scene of 8 seconds, a person will be wearing same shirt, right? Same color dress. So more or less the pixel vector will be unique to that object.
Right.
Yes.
So there will be some corner cases where two people might be wearing exactly same things. Pixel vectors are also identical. So in those cases, it will not be able to correctly say whether person 1 is moving, person 2 is moving. It won't be able to do. But in whichever cases it is able to identify, such as this here, it will be able to correctly cluster those objects. Because the pixel arrays will be more or less same. The pixel intensities in pixel representation will be more or less same. So once we get the pixel array, we calculate the histogram of it. How many pixels are there? Red pixels, green pixels, blue pixels. Their histograms between bucket ranges. So that will be more or less same for the same object. So once we get a cluster corresponding to the same object, then we can always look at the X, Y coordinate and say whether that object is moving, whether that object is stationary, and then generate the text for that. That is what we have done. So the take-home message, what I would like to conclude here is, not all problems can be represented by machine learning. Vector representation is only applicable for gap fill type of scenarios. That means it's only basically interpolation type of scenarios. You have xi mapping to yi, that is the crux of it, through a loss function. The mapping is via vector operations. And there are cases where deductive reasoning has to be used. And in those cases, feature engineering comes to rescue.
Yes, right.
With this, I would like to conclude my talk.
Yeah. So thank you very much, sir. So though we have not got any specific question in chat box, so most of the question has been taken during the session. One of the question I wanted to share, I want to raise. One of my student is working on this metric space based similarity search. So we are, having this difficulty of preparing the data. Okay, let me call Chandradeep. Chandradeep, is it possible you to enable your audio? Chandradeep.
Yes, sir.
Can you brief your problem which we are facing?
Yes, sir. How to convert our data to the binary vectors? Means we are not working on a particular type of data. Means it could be text or images. But how it will be converted to binary vectors?
Okay, so let me answer one question. When I say xi is a vector and yi is a vector, any blob of bytes is a vector, right?
Yes.
Yeah, that's it. It is already in binary form. So as soon as you store data in the computer hard disk or RAM, it is already in binary form. Only thing you have to ensure is that xi vectors, all the xi vectors data set in this point number 5, x1 x2, xn, all of them should have same dimensions. Whether you pad it, whether you do something else, they should have same dimensions. As soon as you have data in a computer, it is already in binary form. Now, what's the question? Yeah.
Yes.
You have to engineer this xi vector. Yes.
Yes. So, okay, we can take other questions also. If any participant is having any specific question right now related to this part, which we have discussed, vectorization or vector representation, we can take, or we can go for the conclusion of the session. Yeah, so I think, yeah, sir. So we have, we have got, a very extensive discussion on this part, because we have started with the, the different paradigm for thinking, and now we have come up with the, how to adapt this vector representation for any specific problem or any specific scenario or application. So thank you for this discussion, sir.
Thank you very much, Dr. Vikram, and thank you very much to all the participants.
Right, sir. So we will be connecting with you in the future also. With this message, I would like to share my greetings from my department and on the behalf of participants. Thank you very much, sir. Thank you.
Thank you very much.